Hello and welcome to another video in this series of Java for Scientific Computing. In this video I'm going to talk about evaluating mathematical expressions when they are given as a string. In order to do that, I'll use first of all, this works. The library that I'm going to use for this purpose only works for real numbers, and again, real numbers are doubles, special numbers such as pi and e, minus square root of 2, and etc. Okay, any real number this works. And I'm going to use the exp4j library, and if you can just Google it and download it from internet, or if you're using Maven, for example, to build your project and manage your project, you can just simply go to search.maven.org and look for exp4j, and here's the Maven dependency. I put it here for you. So the group ID is net.objectHunter, and the artifact ID is exp4j, and the latest version I believe is 0.4.8. okay, I'll show you how to, if you've never used Maven, I'll show you how to use this. Now here's how to use this exp4j library to evaluate strings which contain mathematical expressions. First, you have to define the expression as a string, and then you have to define the variables. Say, for example, this expression has the variables such as x, y. So you basically define a hash map with a string and a double value. So it's a map of variable and value pairs. So you set the variable value pairs in this map, and then you evaluate the expression using the functionalities that are built into this exp4j project. Now if you go and look at the GitHub repository that I introduced a few videos ago, I have a math utils class, and in that class I have two static methods, evaluate. One of them takes a string and a map of a string double pair. Okay, so you can define a string which contains an expression of multiple variables and put the values of each variable into this map, and then this function just evaluates that. Now if your mathematical expression doesn't have any variable, it's just a pure math expression, for example something like your string is something like x 1.2 to the power of 3 times pi. This doesn't have any variables, so you can just use this method, evaluate this string, or use the first method and pass a null value, null object for the map. So if the map is null, it just assumes that it's a pure math expression with no variable. Okay. Now how does the exp4j works? If I want to show you how to actually create your expression and build it, so you define your expression as a string. Okay, so define the string expression, for example x squared minus sine of x times y. So we have two variables, x and y, some operators, the power, times, minus, and some functions, predefined functions, sine for example. And then you define your map, a string double, I call it vars, define variable value map, and then you use the exp4j class called expression builder. So let's call it EB. So you create a new expression builder object and pass your expression to it. And in this expression builder, you set the variables, and in order to have the variables, you just can call the map and get all the keys in the map, because remember, the keys are strings, which are the names of the variables. Now obviously you cannot pass an array list with the duplicate values for the variables, because variables have to be unique. So you pass a set. That's why we're passing a set, and this set can contain x and y. Okay, now that we defined which parts of this expression are our variables. The next thing is to define an expression, and in order to do that we just call the build method. So we tell the expression builder, these are my variables, and now you build it, and it returns an expression. Now that I have my expression, which now the expression knows which parameters in this expression are the variables, and then it also knows what the predefined functions are. For example, sine is a predefined function in the exp4j project. Okay, so you now set the variables, basically the variables and the values. Now you, instead of passing the key set of the map, you pass the whole map, which contains the variables and their values. And finally, after you're setting the variables, you just evaluate the expression, and the result is just a double value. Okay, and the tip here is that you can chain all these lines together, and I'll show you an example of how to do that. So basically, you can start with this double equals result, and you start with this new expression builder, and then after that you add a dot variables, you set the variables, and then after that you add the dot build, and after that you add the dot set variables, and eventually you add the dot evaluate. Alright, so how does it work actually? So we saw this expression. Let's consider this expression, x squared minus sine of x times y minus cosine of x over y. Now if you go into the exp4j archive, Java archive, it has 4 packages and a couple of top level classes, right? I already told you about these 2 main classes that we use, expression and expression builder. So you pass your expression first to expression builder, and then define which characters in this expression are your variables, and then the expression builder creates an expression, builds an expression based on the characters that are assumed to be variables. And it already has some functions built in, so it knows the some built-in functions. So you cannot just use any type of function. It has to be one of the functions that are defined in this exp4j library, and I'll show you which functions have been defined already. And so operators and functions are predefined. That's why we also have an operator package. So we have a function package that contains the predefined functions, and our operator package that contains predefined operators, minus, times, divide, division, the power, and some other operators that we'll look at. And then we have a package called tokenizer. So basically tokenizer takes your expression and creates some tokens. These tokens could be functions, variables, operators, and some numerical types. Okay, so tokens are basically the way that the class, the expression builder, understands how this expression has been created. Okay, what is the meaning of each character of the groups of characters. So once it knows the tokens, then it uses something called shunting yard algorithm. So basically, after knowing what is what in this expression, it has to know how to evaluate them, because when you're dealing with mathematical expressions, some operations have precedence over other operations. For example, in this expression, I cannot evaluate minus before evaluating the power of 2, for example. Okay, so the power of 2 has precedence over minus. And then the other thing is that the general precedence is from left to right? So shunting yard also tries to start from left to right and figure out what these precedences are for the operations. So as I mentioned, the tokens are variables, functions, operators, and some numeric types. Okay, we start with tokens, applies the shunting yard, figures out the order of evaluations, and then you pass a map of the values for these variables, and then it eventually figures out the value. Okay. Again, it works based on the Shunting yard algorithm, and this is from Wikipedia. If you just search for Shunting yard algorithm in Wikipedia, it takes you to this web page, and basically it says that in computer science, the Shunting yard algorithm is a method for parsing mathematical expressions specified in infix notation. Now, I've already told you about the parsing, the meaning of parsing. I told you that in the number classes such as double, integer, there are already built-in parsing methods for just strings that contain a single value a single value for a double or an integer. Okay, but now this project exp4j basically extends that to any mathematical expression. So you can produce either a postfix notation string, also known as reverse Polish notation, RPN, or an abstract syntax tree, AST. The algorithm was invented by someone and named the Shunting yard algorithm because its operation resembles that of a railroad shunting yard. And the Shunting yard algorithm was later generalized into operator precedence parsing. So this you can just click on operator precedence parsing, and it takes you to another Wikipedia and gives you more information. Okay, so this is the basic idea of Shunting yard and evaluating expressions. Let's head to Eclipse. So in the GitHub math library, there is a if you look at the reference libraries, I've already included the exp4j Java archive. It's 0.4.7, but let's say you want to use Maven. So I am going to create a Maven project here. Let's create a simple Maven project. Let's call it demo expression artifact demo x, for example, and then finish. Now we have our Maven project. And in this project, let's just create a simple demo, and we want to have a main method to just evaluate some expression. Okay, string, my string is let's call it x2 minus sine of x times y plus cosine of x over y. Okay, this is the expression given as a string, and then I create a map, string double vars new hash map. Okay, and also need to import the map from Java util, and let's do the hash map again. And it already infers the types, so we don't need to write them. In the vars, I put a string, which is x, one of my variables, and let's put a value of 1.2. Vars put y, let's put 3. Okay, and it's complaining because it's expecting a double, and by default 3 is a integer, so 3.0. Okay, now I need to add the exp4j library or Java archive to my project, and the way I do it is using the POM file, project object model, and you can just go to dependencies, add dependency exp4j, object hunter, this one, and the latest version is 0.4.8. Now that we have it, you save it. Maven already downloads it, inputs it in the repository, your local repository. Okay, now that exp4j is on the build path, let's create an expression builder, eb new expression builder, and we pass our string s, okay, and then eb set variables, eb just we can add variables s dot get vars dot key set, or we can just add them manually, y, x and y. So we set the variables and then we define an expression. Let's import it, expression let's call it e, for example, or ex eb dot build. When you build it, it returns an expression, and then we need to set the values, basically set variables, and it can take a map of a string double vars, okay. And finally, let's get the result. Expression evaluate, and let's print it. System.out.println result, and let's run it. Minus 4.35. Let's just say it's pi, something numeric. Then what happens? It returns pi. It doesn't care. So you can set variables. If it cannot find variables in the string, that's fine. It just evaluates it to whatever it needs to be evaluated. So there's no problem with that. But in cleaner syntax is something like this. Double result. Let's hide all of this. New expression builder. We set the s, we create this, and then variables. This time I'm going to use the map that we created, and from the vars I get the key set, okay. Still complaining about the type mismatch. So we set the variables, and when you do that, then what happens is we build it, okay, and after we build it, we set variables and pass in the values. Basically, we set the variables, basically set the values of the variable using the variable map, the vars map. And once we set the variables and their values, we just evaluate it, okay. And then again we can print the result. Three point 14 15 65, okay. Now the third way, which I already told you, you can use my mathlib class, which is called mathutils, and it is in the util package here, mathutils. I have two methods called evaluate and evaluate. One takes only an expression and it assumes that it doesn't have any variables. It's pure mathematical expression with no variables, so it just builds it and evaluates it. If you pass in a string double map, it assumes that, first of all, it checks whether or not it's null. If it's null, so it calls the previous evaluate function. So it assumes that there is no variable. It's just a pure numeric expression. If the map is not null, it goes through the routines of creating the expression builder, setting the names of the variables in the expression builder, and then it builds it and returns the expression, and then you set the values of these variables, and finally you evaluate that, okay. Now, in order to add the dependency on this project, on our project, we can go to build path, configure build path, and add the mathlib dependency. Okay. And after we do that, I'm going to just say double result equals math utils dot evaluate. My expression is s, and then my variables and values are the vars map system.out.println result. Okay, it still works. Now, because this expression here, the s doesn't have any variable, I can just pass in null to this method and it still works. Okay. Let's put some values, x to the power of 3. Okay, and what happens if I pass in null here? Now it complains. The tokenizer complains that there is a token here, x, that I don't know what to do with it because you didn't tell me whether or not, what kind of token is it? Is it a variable? Is it something else? Unknown function or variable x. So the tokenizer first looks at the expression, and based on the information that you provide, which is a map of which characters or the strings in your expression are actually your variables. So if I pass in the var now the tokenizer understands that x is a variable. This character is already a predefined operator, and 3 is just a number. So tokenizer has no problem, and we will get the result. Okay. Now your variables don't need to just have one letter, one character. They could have multiple characters, and it still works. Okay. Now let's finally look at the inside of the exp4j. So as I mentioned, there are 4 packages here and 2 main classes here. One is expression builder and one is expression. So let's start with operators, and I'm going to decompile this operator class. One is operator, the other one is operators. And these are all the operators that are predefined: plus, minus, times, division, percentile, this power, exclamation mark, hash mark, $, and semicolon, colon, tilde, less than, greater than, this symbol, and equal. These are allowed operator chars. Okay, and operators has to only be one character. And then in the operators class, it basically gives these operators some index, and these indexes, I assume, are going to be used in figuring out the operator precedence in the expression. Okay, that's why it gives them index. In the functions class, again, we have a function that has some methods and then some functions. And these are the predefined functions: sine, cosine, tangent, cotangent, log, log1p, absolute value, arccosine, arcsine, arctang, cubic root, ceil, floor, sine hyperbolic, square root, tangent hyperbolic, cosine hyperbolic, power, exp1, log10, log2, and sgn, which is the sinum or the sine function. Okay. Now, in order to use these, let's create sgn of 3, and let's run this. Now it doesn't know sgn because the spelling is wrong, so we use sign, sign. It still doesn't know what sign is. Let's use abs, for example. 3, abs of -3, 3. Notice I'm passing in the vars, but it doesn't care because it cannot find it. If it cannot find these variables in this expression, it's fine. And we can try other functions, for example sqrt of 3 or 4, for example, which is 2 of 2 should be 1.4 something. Yeah, so square root 4 works. Let's try power, for example, power of 2 to the power of 3, still 8. Okay, so power works. And you can try other things, for example like 10 of 2 should be 0.3, and then let's multiply this by like 10 of or add it like 10 of 5, and we know that this is equal to like 10 of 2 times 5, which is 10. So this should return 1. Yes. So you can use all these functions, and let's see what is the actual literal for the sign name. Okay, I was using sign. We have to use signum. So sign name of -1, it should return -1.2. It should return -1. So sign function returns either -1, 1, or I assume it returns 0 for 0. Yes. 1.3. Okay, 1. Yeah. Alright, this is the expression builder. If you're using Maven, you can always get this library from Maven Central. It's very easy to use. Let's go back to here and recap one more time. So you start with your expression. You have to create the expression builder and pass it to the expression builder. Internally, expression builder runs a tokenizer to first of all digest what is what in this expression. Okay, and in order to do that, you have to tell the software or tell Java what characters or what strings in your expression are your actual variables, right? For that, you have to use your expression builder object and set the variables, and then based on that and the predefined functions and operators, you can build the expression, call the build method in the expression builder, and eventually you get an expression. Now this expression has been fully tokenized. The only thing remains is the precedence of the operations, which operation is first, and that is internally done in the expression object using the shunting yard algorithm, right? So finally in the expression, you set the variables of these, set the values of the variables. And I find it very easy to just in the beginning define a map of the string double pairs and then use that to build the expression and set the values, and finally you evaluate your expression. Okay, that was very simple. Thank you very much for watching this video, and please like and subscribe. I'll see you next time.